Hey everyone, welcome back to another Ask GN episode. As always, leave your questions in the comment section below for next episode, or if you're a Patreon backer, you can leave them in the Patreon Discord. We also have a second extra patron to Ask GN video that'll go up separately from this and will be available only to Patreon backers. So if you're interested in that one, go to patreon.com/GamersNexus to get it. Otherwise, we've got the full-length normal episode here. So before that, this video is brought to you by EVGA and the X299 Dark motherboard for the Intel high-end desktop CPUs. The X299 Dark is one of the only motherboards on the market with proper VRM cooling. We've tested this and found significant performance increase over those without active cooling on the VRMs. This board was used in our recent attempt to set a top 10 record in Firestrike, and you can learn more about the X299 Dark at the link in the description below. So prior to the questions, this is the CPU or APU that we got in from AMD from part of that boot kit that we reviewed. And if anyone was curious, I haven't sent it back yet, obviously. I got an email reminder from the warranty program. It was all automated that just said, you need to send this back within 15 days. Otherwise, you're not going to be able to use this service again. So, I mean, I'll send it back. I have really no reason to keep it. But I was curious about what would happen. If anyone was curious, that's what happens. They basically say you can't use it again. So it doesn't look like I would be charged for it or anything like that. But anyway, that's going back soon. First real question is an interesting one that I've been talking with AIB partners about lately. This is from David Watson, who said, "Hey Steve, do you think we will end up seeing NVidia competing with aftermarket cards more directly by releasing their own non-Founders Edition cards with new custom cooling solutions and heatsinks with double or triple fan designs? I think it's a fascinating prospect and one I feel NVIDIA has had a lot of thought bent on and is surely bound to use much sooner rather than later, because if they can get more market share, they surely will. And I honestly feel it's coming from NVIDIA and could be massive for them." So, do you feel this is on the horizon? I don't. Like I said, this is something I've spoken with a lot of people about, because you look at what NVIDIA has done, and they've introduced reference cards, which both vendors have had for a long time, but they've introduced reference cards that are separately branded and also, more importantly, sold directly by NVIDIA. AMD has done things kind of like this, but not quite the same. So the best example with AMD would probably be the Fury X, where there were no partner designs allowed. It was only AMD's design. That was it. But you still ultimately bought the Fury X from Sapphire or Asus or whomever. So this is a little bit different, although not too much, but they're different enough. So NVIDIA, they have their Founders Edition cards that they sell directly, currently at a pretty good price considering the market, because they've stuck to about MSRP, and the only other way to get MSRP cards is basically go to EVGA's website or any of the other manufacturers who have a store and buy it from them, because the retailers aren't going to help you out. So do I think it's on the horizon? I don't know. I don't feel like this is something we'll see anytime soon. That said, certainly NVIDIA is in a good place where if they wanted to make a better cooler, they could do it. It's not. They make silicon product. It's not that much harder to make something with two fans on it. So it's not like there's a technical hurdle there. The only thing that's stopping NVIDIA from making better coolers on their cards is the fact that they have partners who can do that for them. So why put the expense in? There's extra marketing work that EVGA and Asus and all of them can do for you. They can handle the entire warranty process. They can handle shipping and distribution. So there's a lot of advantage to having partners handle all of these things, because it's all logistics and SKU tracking and management of inventory and management of warranty and RMA and all this stuff. And NVIDIA spends their money on R&D and engineers for the most part, and their own marketing, obviously. GeForce and all that stuff is all marketed. But there's an advantage, certainly, to having partners. So it's not like they provide no service. And their coolers are pretty good, of course. But the coolers are probably the weakest aspect of the entire argument, because, like I said, it's not that hard for a company like NVIDIA to make a cooler like the ones that their board partners make. So, yes, I've spoken with some board partners about the idea, and this is just kind of like casual conversation in the past. It's something that people are distantly maybe anxious about, but I don't have any reason to believe that this would happen anytime soon. That said, NVIDIA sometimes does almost feel Apple-like in some of their marketing and the way that the company carries itself. I'm not saying that's a good or a bad thing, but in terms of building a product and having a really clear distinction of like, this is the product by our company. Like Apple's got the MacBook or whatever, I don't even know the product names, but they have their product and that's it. That's the end of the line. That's the start and the end of it. And they build this whole marketing hype around it, and they control all the messaging on it. So there are advantages to both approaches of having partners and not. Apple, if you take that analogy, certainly has its own challenges, like with price, but also the Windows products have a lot of their own challenges as well. So yeah, I don't know. I don't think this is something that's on the horizon anytime soon, but I guess the only valuable information I can provide here is that this is something that we've all kind of talked about behind the scenes and have wondered about, but there's no concrete evidence to suggest that NVIDIA would compete with its board partners directly at this time. In fact, when the Founders Edition cards launched, and they got a lot of flack for this, but when they launched, the Founders Edition cards were, I think, $50 more than actual MSRP for the board partner cards. And so they were actually distant. They're further away from competing with those partners because their cards are more expensive than their board partners in most cases. So yeah, no evidence to suggest that this would happen anytime soon, but it's been thought about. Next question. Stank Buddha says, quick question regarding the 200 FPS limit in newer ? Games. Is this applied per monitor if you're using multi-monitor, or is it a game that's locked to 200 FPS total? It's the game for the most part. So Doom does this, and I think maybe Destiny. I think Destiny does as well. So with Doom specifically, I know what the cause of that is. Doom limits to 200 FPS because of a physics issue. In fact, the Doom team, they batted for both teams, NVIDIA and AMD, at different points in the development cycle. Earlier on, it was NVIDIA. NVIDIA brought the Doom team out to a press event, I think for the GTX 1080, and they showed the game and noted that it was capped at 200 FPS because of a physics bug that the team was working on resolving, hopefully before the launch of the GTX 1080. Obviously, that never happened. It never got fixed. They came out later to some AMD event. I want to say it was the Polaris one. The same bug existed. There was no further conversation about it. So the limit you're seeing, typically, if it's not because it's like console port that's been poorly done or something, if there's actually just a kind of random high FPS limit, it's often physics. Skyrim and Elder Scrolls games and Fallout are great examples of this as well. There's a 60 FPS. You can unlock the FPS, and if you put in a powerful enough set of hardware and lower the settings enough and really blast your frame rate, you can do pretty crazy things with physics just because the game bases the physics calculations on the frame rate. So locking it to max 60 resolves that. But once you start pushing like 400 frames per second, you can really break the games. So yeah, it is not to do with the monitors unless it's a VSync thing. If it's game engine bound, meaning you've turned off VSync and you still have a cap, then it's probably because of a game engine limitation. Often the physics calculations, if they do it based on frames. Next question. Michael Morgan says, can you demonstrate the end user benefit of HBM memory over GDDR5 or G5X on GPUs, please? So we've talked about this. First, let me refer you to a previous video of ours that was about how much HBM costs. This was specifically a video talking about the cost to manufacture Vega products, and the HBM was a large aspect of that. So in that video, we make the point of why AMD chose HBM, how they were more or less required to use it for that particular product, because although it would have been cheaper with GDDR5 or 5X even, it would not compete as well. It wouldn't compete. So HBM's got a lot of advantages to it. One of them is power consumption, and I have all the specific numbers in that video. I don't actually have them in my head anymore. We filmed that a while ago. But power consumption is much lower with HBM per gigabyte. In an ideal world where HBM cost is something we don't have to think about, you would use HBM on basically everything because the power consumption is lower. So from strictly a standpoint of being energy efficient, which helps elsewhere, like in thermals, or just, I mean, there's no reason to waste power. In being energy efficient, HBM is superior, especially for the performance. It gets a bit more complicated than that. With AMD specifically, the Vega products and the Fury previously were already such high power consumption that requiring that much more for GDDR5 is starting to become a problem in terms of your power requirements for the whole board, all of it, not just the GPU. And then also further, depending on the type of memory you're using with the GPU and the GPU architecture, it's possible to become memory bound. And this happens with, it's actually, we have, to answer your question, can you demonstrate it? We have demonstrated it with the AMD products again, because they primarily are the ones that use HBM. With the AMD products, we've shown that increasing the HBM clock, overclocking HBM, rather than just a core clock. In fact, you downclock the core. Overclocking HBM will generally, typically up to a point of diminishing returns, get you greater gains in performance than the core. And that would be the beginnings of indicating that there is a memory limitation. It's not all there, but in the other tests we've published, and we did a lot when Vega launched, you can more or less draw the conclusion that it typically becomes bound by memory before anything else. So in this instance, because HBM is advantaged, although they have fewer stacks of HBM on Vega, they went with 2 stacks instead of 4. So you are still running a thinner bus than on Fiji. With Fiji, you had 4 stacks, so I think it was a 4096-bit bus, but it was HBM1, so fewer bits per pin. So you end up with, I think it's 2 stacks on Vega with HBM2, so it's a thinner bus, 2048 or something, but it makes up for it in the frequency of the memory, which is much higher. It's like 945 instead of 500. All these numbers off the top of my head, I think they're pretty accurate though. So yeah, the answer though is HBM is basically a requirement on GPUs that become memory limited or GPUs that have serious power consumption issues already, where you can't afford another 30, 40, 50 watts for GDDR5, especially at the capacities that HBM can do in the same space for the power that it takes. And we do have a lot of great content on that, so just search the channel for HBM or for Vega and find some of the stuff we posted when it launched. I think we also did some HBM testing on the Titan V, where we, same thing, overclock HBM versus core, what happens. So you can find that content as well. Next question is Vishal Bobde, who says, why do CPUs not have different manufacturers like GPUs? If there are more manufacturers, we might get more enthusiast features from the factory, like liquid metal, TIM, and better IHS. So first of all, ideally, you use solder, not liquid metal. Liquid metal coming out of the factory doesn't make a lot of sense. If they're going that approach, it makes more sense for them to just solder it at that point. So liquid metal is more of an enthusiast thing, as you've pointed out, but it doesn't make a lot of sense manufacturing. Once they've gone that far, solder is where you go. It makes more sense for the manufacturer. Better IHS, sure, that's certainly possible. But yeah, so the general answer here, why don't CPUs have different manufacturers like GPUs? Consider the market, I guess. So with GPUs, you've got NVIDIA and AMD, they make everything. With CPUs, obviously, Intel and AMD make everything. But GPUs require a whole lot more than just the single part. You don't just buy a GPU from NVIDIA or from AMD and then socket it into a board like you buy a CPU and you socket it into a motherboard. So a GPU is fitted with enough special requirements that it makes sense to have those board partners. You have different sources who supply the memory. You could get it from, at one point, or these days, Samsung, Hynix, Micron, for example. So someone needs to take control of where the memory is coming from. Makes sense to put a manufacturer there. They pick the memory supplier. They pick a PCB supplier. They design the PCB. They design the cooler. They pick suppliers for the cooling components. So there are a lot of suppliers that go into a single GPU, or a single video card, I should say. And I suppose you can make the argument that why don't companies like Intel just make the motherboard? Because that would be the equivalent. It would be if NVIDIA and AMD made their own cards, then Intel would make their own motherboard. Well, and Intel did make their own motherboards at one point. It didn't go too well. They had a lot of issues controlling it. And part of that, I think, does come down to what I was saying earlier with logistics and part tracking, warranty, all of the supplier relations. Certainly a company with a market cap of $150 billion or whatever it is these days could make that stuff work. But they tried and they didn't do a great job of it. The Intel motherboards went under. They even had that whole Better Together branding as well, which AMD's tried similar types of branding. But I don't have a great answer specifically why. But from industry experience, if you kind of look at the whole picture of things, it makes sense to me that with something that's a socketable part, like a CPU, you just make it and you sell it direct. Because cut out the middleman. Kind of like what we were talking about with NVIDIA. Why doesn't NVIDIA cut out the middleman? Well, there are a couple of reasons to keep them around. Intel tried to cut them out with their own motherboards. Didn't go over. So I don't know. That's kind of how I look at it. Intel also, if you kind of look at how they're making the parts, NVIDIA and AMD don't fabricate their own GPUs. They go through partners, Global Foundries, TSMC, people like that. Intel owns their own fabs, which is quite a bit different because that's all in-house. And they already don't have middle people to make the thing. So why have middle people to brand it and put a heatsink on it, I guess? Because that's really the only difference you have, at least with GPUs. You have a couple more things you can specialize. So yeah, I don't know. That's how I see it, I guess. But next one, we have a celebrity question. This is from Satoshi Nakamoto. I believe it's the real one. We found him. He was on our Discord. I don't think that surprises anybody. Satoshi says, of course, hey guys, could you reach out to Thermaltake and ask them if they have any idea for the arrival of the level 20 case? Well, Mr. Nakamoto, if I may call you that, the level 20 case, I sent this question to Thermaltake, not sure whether it was a joke or not, and apparently it's in a high demand. A lot of people want to know when it's going to be available. There's not a hard date yet. They're pushing to get it out. Keep your eyes on their social media channels. They're just finalizing all the production and everything like that, so it shouldn't be too long. For anyone who doesn't know, that's a $1,000 case, so it would make sense that the god of Bitcoin, I guess, would want one. Next question. Defenestrationize, throwing people out of windows, says, Steve, a massive limit for APUs. Is there need to use system memory? Do you think APUs will remain on the low end or end up high end? Is there not actually a limit to DDR for APUs? More memory channels on APUs, or will more memory channels appear in the future on APUs? Given how board partners operate and push for chip consolidation, do you think we might see a motherboard, RAM, GPU, CPU as a single PCB? I think there's a couple questions here. So first one, do I think APUs will end up in the high end? How do we define high end? If our definition of high end is competing in graphics capabilities with a 1080 Ti, then no. If our definition of high end is competing with what I would call mid-range, maybe let's say a 1060 or an RX 580 or Vega 56, something kind of in the $200 to $350 in an ideal world price range, I still don't really think so. Not today, but APUs are cramming a lot of processing power into a small space. AMD's done a great job where they realize that these are for gaming devices. Intel puts an IGP in everything they make, basically. They take less die space to put that IGP in there than AMD does for their graphics components, because Intel is probably under the assumption that you're buying the i7s and coupling it with a DGPU. AMD took the other approach of saying, if you're buying something that's $300+, then screw it, we won't include an integrated graphics component. We'll use all the space for the dies for the CPU, and then you can go buy your own graphics card and deal with it yourself. And then they also make the assumption that at the low end with APUs, you probably, if you're spending $100 to $170 on it, are buying it for gaming. And so if you're buying it for gaming, the GPU component sort of matters the most, provided that you have enough frequency and a couple of threads from the CPU. So with that provision, I don't think that AMD is going to be cramming like a Vega 56 equivalent into an APU anytime soon. Look at how much space Vega 56 takes, right? The die size alone is a concern. You start eating more of the shared die space or the shared substrate for a bigger graphics component. At some point you run into limitations. As we advance in the future, it'll get that direction. I don't think there will ever be, though, in the immediate next couple years, I don't think there will be an APU that would go properly high end, like 1080 plus in modern day terms, because although an APU in maybe 5 years could do what a 1080 does today, I don't think it's going to do what an AMD like Vega 76 or whatever does at that point in the future. Next question, though, but they are good, though. The APUs are good. They do the things they're supposed to do, but it's not meant to be that kind of component. It's you're asking to cram too much into one spot, I think. Could happen in the future, though, distantly. Next part of your question was, let's see, consolidation. A single motherboard, RAM, GPU, CPU, PCB. It kind of exists to some extent. You can get basically BGA devices. You look at laptops, that's more or less what you're talking about. Let's take the Apple example again. Apple solders it all onto one board for the most part. Soldered CPU, it's all BGA, ball grid array, soldered memory, soldered flash components in some cases. It's all soldered. So that's, I guess, kind of what you're talking about at that point. It does exist, it's typically in really small form factor applications where having modular components doesn't make sense because of the space requirement or the thermal concern. Let's see, next one. So this one, we'll come back to this more in the future once I get around to the fan testing content at some point. But we can do the basics now. Dane of Starfall said, I'm a bit confused by case fans lately, specifically RPM and in relation to voltage. If I understand correctly, different fans have different max and minimum RPM at a given voltage, but what happens when you connect two fans with different RPMs to a single header on the motherboard using a Y splitter? So yes, you do understand correctly. If I take 10 Noctua NFA14s, which we've actually done, and plug them into the same motherboard header and spin them up to max 100% versus whatever the minimum voltage is, you'll see different RPMs, and that's manufacturing tolerances. As for, I think part of this question was about fire. I've read on forums that the cable or port can catch fire if they draw too much power. Is this true? It's always possible to make a fire with electronics, but it shouldn't really happen. So what you're asking, basically, the fan headers on motherboards are typically rated for 1 amp, and the high amperage, or HAMP is typically what it's labeled. High amperage headers on motherboards are often rated for 2 amps. Not always, check your motherboard manual. But if you plug a Y splitter into a 2 amp header, you're probably going to be fine. If you plug a splitter into a 1 amp header and then you plug a bunch of fans into it and run them at max speeds, you might have problems. Theoretically, you shouldn't start a fire, but yeah, it comes down to how much current the header can handle. It's 1 or 2 amps typically. So just be reasonable with how many fans you're plugging into the Y splitter. And then you had some questions about PWM and stuff. We'll come back to that with our fan content in the future. A couple more quick ones. One of them, so this one, how do delidded with, from Ashbore, how do delidded with liquid metal temperatures compare to soldered CPU temperatures? Do you ever plan to delid a Ryzen CPU and test the results? I'm under the assumption that delidding provides better temperatures, so I don't mind that Intel doesn't solder anymore. As an enthusiast, I want to delid anyway, and if it's not soldered, it's easier to delid. if it's soldered, you won't have to delid, is more or less the answer to that question. If it's soldered, they've done all the work for you. There's no reason to have liquid metal. It's going to perform within a couple degrees in the best case scenario, and solder maybe a bit ahead, maybe a bit, I would assume a bit ahead. Der Bauer did a video on this. He delidded a Ryzen 7 CPU, and the variance was not that great. So, yeah, I mean, same, what I just said is all that needs to be said, I guess. If it's soldered, delidding is basically irrelevant at that point. Next question, Armand B. Modmat out of stock? Damn miners. Yes, well, the GamersNexus anti-static Modmat is well known for being used in factories in China that are filled with GPU mining equipment, I guess. If you want one, though, they're on back order, and they will be shipping end of this month or early next month. So get them before the miners do, I guess. Last question, Nory The Explorer.exe. What is an important fact viewers should know about GamersNexus? And the opposite, what is a big misconception viewers have expressed about GamersNexus? Important fact, if I'm taking it seriously, is probably that we've been doing this for about 10 years. So a lot of experience in the game. Started with gaming content almost exclusively. Didn't really get into PC hardware stuff till maybe 2010. In terms of like editorial work, I'd always worked on it personally. But PC hardware, maybe 2010, 2012 areas where I started getting more serious about it and basically pivoted the site to hardware coverage instead of games coverage. Gaming coverage, it was interesting. I have a lot of contacts in the game industry still, but we obviously don't talk to them as much anymore. It was interesting because it gives you a really good understanding of things like game graphics, game programming, game engine limitations, all of these things that if I had started and stayed in hardware, I wouldn't really understand. And so knowing a bit extra, obviously there's an impossible amount to know, but knowing a little bit more about game development and game engine development from those starting years before we got into hardware has been really helpful in understanding how to test different aspects of games and in understanding how the games interact with the computer hardware, what happens when you toggle different settings on, what do the settings names even mean. That's all stuff I learned from the early days covering basically games exclusively about 10 years ago. So I would say that's an important fact that people know. We started as a games coverage outlet, and it has provided me with a unique perspective on hardware coverage that I think we've been able to leverage with some things like our Final Fantasy coverage recently. Misconception. I think Budokai in the askgn basically answered this for me. Something about shredding NAR. I'll use that as an opportunity to plug the GN Steve side channel where we've been uploading our Patreon behind the scenes videos. Some of them go live. Subscribe to that channel if you haven't, because every now and then we'll set a Patreon behind the scenes video public for everyone, and that's where it will exist. So if you're subscribed there, you'll get it. As far as shredding NAR, I've got some downhill mountain biking videos over there where I've done things like talk about Coffee Lake and Ryzen while riding down the mountain at Whistler, and I don't know, we have some A-line footage or something we can show while we're at it. So that's it for this one. As always, subscribe for more. Go to patreon.com/GamersNexus, helps out directly, or get the extra version of this AskGN, and store.gamersnexus.net to pick up one of our Modmats on back order. They'll be here very soon for the second round. So thanks for watching. I'll see you all next time.